What's up, y'all? This is Hussein Nasser from iGeometry Podcast. Good morning, everybody. It's 5:30 in the morning. Heading to work. Today's topic is asynchronous versus synchronous operations. Yeah, so in order to talk about these two operations or methods or style, really, of programming, we need to understand how the basic operations work. So I'm writing a program today, right? Writing a code, any language, JavaScript or C#. And let's take this program for an instance. You have a variable called A equal 1, and then B equal 2. Then you have another variable C equal A plus B. So what will happen here is, as long as the statement or the program is concerned, what happened here is each statement is getting executed in sequence, right? So A first will get the value of 1, then B will get a value of 2, and then C will get the value of A plus B, which will be sent to the CPU to do the processing of adding, the computation of adding 1 plus 2, and then we'll return the results to C and store it into C. So we need to understand that the third statement here, the rest of the program had to wait for that operation to complete in order to persist these values into the C, and then continuing with the rest of the program. So this is the traditional style of doing things, which is synchronous, right? It's synchronously, just sequentially execute, wait for your result before continuing, right? So this might be almost negligible if you think about it, right? Because adding A plus B is just a small computational overhead. It's not even an overhead. But so waiting is not really it's not really a concern here, waiting for that result. However, there are other operations that we execute, and that these operations are more expensive to block the user from doing anything else, just wait, and you can think of few of these examples, like read or write to the disk, right? Querying something on the network, accessing the internet, right? Accessing the internet for pieces of information. So these operations usually takes a few more milliseconds, or even more. Sometimes it depends on what you're doing, right? So if you decided to write your application in a synchronous way, the user will feel it. He says, why is your application slow? Okay, I clicked this button, I understand the consequences, and I'm willing to wait, but let me do something else. This is the trick for the asynchronous operations, and this is coming up, guys, in the next segment. So In the previous segment, we discussed synchronous operations, where the program literally blocked while waiting for a result from a single operation. So this is a synchronous operation. So stop everything you're doing, all right? So stop everything you're doing and let me execute that and wait for that result, because that result, we're gonna use it to do something else. And that's the trick. That's the actually the good part of the synchronous thing, right? Because it's always depending on something else. That if I'm doing something, I'm gonna use it to take that value of C. In our example, A plus B equals C. I'm gonna take C and then divide it by 2, for example, right? So this is like the synchronous operation. The sequence really matter, right? So, however, asynchronous now. Let's go discuss asynchronous operations. Asynchronous operations says, okay, I know that this function that I'm about to execute will gonna take time, and it depends. Sometimes it's gonna take a few milliseconds. Sometimes it's gonna take more than a second, depending on the mood, right? Because if I'm writing to the desk, if the disk is fragmented, right, it's gonna take longer. Especially if I'm reading, actually, if I'm reading a piece of file, that file is fragmented. I have to go the disk I/O has to go and pull these pieces together and compile that file, or creating file for you, and then return it for you. So that's really an expensive operation if you think about it, especially if you do it over and over and over again. So you have to design your program if you want to go asynchronous, and that's example JavaScript almost supports always asynchronous. It's up to you how to activate that or not. So it's like, okay, I have the file now. I have this operation. Go and execute that, and hey, whenever you're ready, call this function and tell me that you're ready. Or sometimes it's called delegate in C#. Sometimes it's called callback functions in JavaScript mostly. Right? So do your thing and then return. Whenever you return, just like think of it like a bell, right? So you send someone to do some task and say, hey, whenever you come back, just ring this bell. Let me know that you're back. Ring that particular bell. That bell is actually the function callback. So in our example, if I want to convert my my application, the A plus B equals C, into an asynchronous application, what I'm gonna do is I'm gonna write a function called sum. Right, that's one way to do it. And then that takes A plus B, and then what does the computation, and then what we will do is that sum function will take actually 3 things: the A, the B, and the third parameter is actually the callback function. Which function should I call with the result when I'm ready? So that's the callback function. So you call the sum, A, B, and then the callback function. And you go on your merry way. So what you do is A plus B, you call that function, and then you continue. That program is completely open. The user can do whatever she wants, right? Click on other buttons, do other things. Whenever the value of C is computed, that function will be called, and guess what? You'll be ready for it because you have already written code for it. That's sometimes called an event, like a click event happened or something happened, right? So it's like on ready or on completed. And that completes our second segment. Thank you guys for listening. See you in the next one. Now that we discussed sync versus async operation. Now it's time to see what are the advantages and disadvantages of each operation, right? Or each style. The synchronous, although the advantages is clear coding, right? You can clearly see that I added A plus B and I stored the value in C. Very clear. The program is read from top to bottom, right? Very simple, clear, to the point. And disadvantages, slow operations like reading from disk, reading a file from disk, reading REST operations, right? I called the method on the REST API from the REST API. That takes time, so you're gonna wait for that to return in order to continue, in order to unblock your user interface, in order to do other things as well, right? So simple coding, kinda bad. I wouldn't say bad, but it's not optimal user experience. Now, async. For asynchronous, the advantages is, hey, I call a method, I don't care how long it takes. Well, I do, but it's not gonna take forever. But I still can do other thing in my application while calling that method. So function calls to read the disk or read the file, read the REST API, or read any method in the network will get executed, and then it will return as a callback function. And then whenever it's ready, I'll be ready for it. I'll do my thing in my callback function. My callback function has, for example, print C, or take the value C and divide it by 2 and do something else. But probably this is good as explaining a vlog or something. So the podcast will be really high. All right. So, disadvantages of asynchronous code. Asynchronous code, the disadvantages is, and everybody agrees on this, is the readability of the code. It is tough to read the code. So, if you do C is equal A plus B, or A plus B sum A plus B callback divide, or do something with the C, the rest of the code below that will get executed anyway. So you have to be very careful, because it's like it will just, hey, make the call and then just continue executing the code below that statement. So that can actually lead to tricky programming. So you need to be really know what you're doing, because you can't read it synchronously anymore. You have to jump through different functions, especially if reading something else. It's really hard to do, to debug asynchronous code. It's really challenging. JavaScript, actually, and other languages as well, took care of this slightly. So you still can have an asynchronous code, yet it feels like it's synchronous by using promises and hey, do that and I promise you I'll call this function when I'm done. But it's done in a very neat way, so you can just, it's very readable. It's even called using the keywords async and await. So you'll call a function called async and then await that result. Although you said await, but it's actually executed in the background, but you still have the code for you to do whatever you want. All right, guys, stay awesome. See you in the next episode. Take care.